From UFOs to the most convincing proof yet of life beyond Earth, a new discovery has shaken the scientific community. The planet K218b could be home to life. On April 17th, NASA released data that could completely redefine our understanding of the universe. Signs of life were found on this distant world with an astonishing 99.7% probability. Located 124 light-years away, K218b's atmosphere contains chemical compounds that, on Earth, are almost always produced by living organisms. Even more striking, their concentration is 1,000 times higher than ours. If these substances truly result from biological activity, we may not just be looking at life, but at a thriving ocean teeming with alien biology. Everything points to K218b being a water-covered world, a vast ocean planet possibly filled with exotic, thriving ecosystems unlike anything on Earth. The story of K218b began in 2015 when the Kepler Space Telescope, during its K2 mission, identified over 1,200 distant planets. One stood out: 218 billion, nearly 2.5 times larger and 9 times heavier than Earth. In 2017, data from the Spitzer telescope confirmed it sits within its star's habitable zone, where liquid water can exist. Further observations from Chile's HARPS spectrograph revealed its density hinted at an ocean beneath its surface. By 2019, the Hubble Space Telescope detected water vapor in its atmosphere, a massive breakthrough suggesting real potential for life-supporting oceans. Then came the James Webb Space Telescope. In 2023, it found traces of dimethyl sulfide, DMS, a gas almost exclusively produced by life on Earth, primarily by microscopic ocean organisms. If accurate, this would mark humanity's first verified detection of extraterrestrial biology. But one telescope alone wasn't enough proof. NASA needed confirmation. On April 17, 2025, the James Webb used a different instrument, scanning K218b in the mid-infrared range. The results shocked scientists. The DMS signal was confirmed, with concentrations 1,000 times higher than Earth's. Because DMS breaks down quickly, it must be constantly replenished, meaning a continuous biological source might exist. On Earth, that source is life. Detecting such gases from 124 light-years away might sound impossible, but astronomers achieved it by studying the starlight filtering through the planet's atmosphere during each orbit. The atmosphere acts as a fingerprint, absorbing specific wavelengths of light that reveal its chemical makeup. From these light patterns, scientists reconstructed the atmospheric composition, giving them a glimpse into what K218b might really be: an ocean planet orbiting a small red dwarf star. Despite being much closer to its star than Mercury is to the Sun, K218b receives roughly the same heat and light as Earth, due to its star's smaller size and cooler temperature. It fits the classification of a Hyson planet, one covered by deep oceans beneath a hydrogen-rich atmosphere. Interestingly, scientists found no ammonia in the atmosphere, strengthening the case for vast liquid oceans. However, it might not be paradise. Some models suggest these oceans could be superheated, creating boiling conditions that make Earth-like life impossible. Others propose it could be a mini gas giant without a solid surface, which would rule out life altogether. Yet, Professor Niku Madhusudan of Cambridge University, who leads the research, believes the evidence supports the presence of life. His team is confident that within a few years, they'll have the data needed for absolute confirmation. Currently, the probability of biological signs on K218b stands at 99.7%, the most reliable extraterrestrial biosignature in history. For perspective, the famous Higgs boson discovery in 2012 required a 5 sigma confidence level, 99.9994%. Scientists aim to reach that same standard before declaring life. Still, the fact that we're this close is astonishing. K218b's relative proximity, just 124 light-years away, feels almost next door in cosmic terms. If life is found there, it suggests life could be common across the universe. The discovery would rewrite our understanding of existence itself. But what might life look like there? If it exists, it likely began as microscopic organisms, extremophiles capable of thriving in high-pressure, hydrogen-rich environments. Similar to Earth's deep-sea microbes living near hydrothermal vents, these life forms could survive intense heat and darkness by drawing energy from chemical reactions instead of sunlight. Over billions of years, some might have evolved into larger, more complex beings. In the perpetual twilight beneath thick clouds and deep water, vision would be nearly useless. Instead, these creatures might navigate through heat detection, vibration, or magnetic sensitivity. Many could emit bioluminescent light, creating glowing ecosystems in the dark oceans. The low density of hydrogen could even allow for enormous life forms. Slow-moving giants with flexible bodies adapted to crushing pressures. Imagine colossal jellyfish-like beings or floating amorphous creatures gliding through warm ocean currents. Some might even drift through the atmosphere itself. With pressures reaching thousands of atmospheres, far beyond the Mariana Trench on Earth, these beings would need ultra-strong biological shells or flexible structures made of organic polymers capable of withstanding immense force. Though purely speculative, such adaptations could exist if DMS truly indicates biological activity. If so, alien life might already be thriving in the hidden oceans of K218b. While K218b is currently the most promising candidate for extraterrestrial life, it's not alone. Take Teegarden B, just 12.5 light-years away. Its conditions might be 60% similar to Earth's, with moderate temperatures and possible liquid water. But it's likely tidally locked, meaning one side always faces its star while the other remains in perpetual darkness. The narrow twilight zone between these extremes could host temperate conditions suitable for life. Then there's Kepler 1649c, discovered in 2020. Located 301 light-years away, it's slightly larger than Earth and orbits a calm red dwarf, receiving about a quarter of the sunlight our planet does. Like Teegarden B, it's probably tidally locked, but a twilight band could still support liquid water and primitive life. Another strong candidate is TOI 700d, located 101 light-years away in the constellation Dorado. It's nearly the same size as Earth and receives about 86% of our sunlight. Temperatures hover around -4 degrees Celsius, but with a greenhouse atmosphere, it could maintain comfortable conditions. What makes TOI 700d particularly exciting is that it may not be tidally locked, allowing day and night cycles similar to Earth's, an ideal condition for sustaining life. Beyond these promising worlds, space offers bizarre and extreme planets unlike anything imaginable. Take J1407b, located 434 light-years away, a super Saturn with a massive ring system 200 times larger than Saturn's. Its 30 gigantic rings span 120 million kilometers, making it one of the most visually spectacular planets ever found. Kepler 70b, about 650 light-years away, is an inferno. Once a gas giant, it was stripped by its dying star and now consists of a molten iron core hotter than the Sun's surface, over 6,600 degrees Celsius. Similarly, WASP 76b, 640 light-years away, rains molten iron. Its tidally locked sides create violent winds that carry vaporized metal from one hemisphere to the other, where it condenses into iron rain. One final cosmic wonder is 2MASSJ 2126. Once thought to be a rogue planet, it was later found orbiting a distant star at 1 trillion kilometers. 7,000 times farther than Earth is from the Sun. 1 year there equals 900,000 Earth years, making it the planet with the widest known orbit. And finally, the exoplanet PDS-70c gives us something extraordinary: the first ever observed moon-forming disk around a distant planet. Using the ALMA telescope, astronomers detected a swirling ring of gas and dust that could create multiple moons the size of ours, a snapshot of moon birth happening in real time. Each of these worlds, from K218b's mysterious oceans to J1407b's colossal rings, reveals how diverse and strange the universe truly is. But among them, K218b stands as humanity's most promising clue yet: a shimmering blue world that might already be alive. If confirmed, it wouldn't just mean we're not alone. It would mean life is a universal law, written into the stars themselves.